Here we go. 5-6, 5-8 is more factoring. Okay. So they're a little bit more intense factoring. There's some other ones that I'm not going to talk about but there's something that you guys said about maybe a little bit different. Is something like this. No, come on. All right, here we go. Something like that. Okay, we already know how to factor that thing. How do we do so? I like to do my rainbow. You guys might have other ways. How many of you guys are doing it a different way than what I'm doing? It's completely fine. Anybody look in the book how they're doing it? How they showed you? They did every single possibility. So for example, they did this. You have 4x, right? This is how the book did it. X. What's our possibility for 9? Is that our answer? Is that 36 plus 1? And then they say, okay, what's another option? They're making you do the guessing technically. Hey, making sure you have your thing. I got an email from you. Have it out there. How are you today? Good. Connor. Boy. This is even. And obviously this one would be it because notice that 4x plus 9x, which is 13x. That's not it either, huh? What's our other option? Instead of 4, it should be here 2x and 2x, right? Then I have the options of what? 3 and 3. Oh, that one's work. That's really what they did. You something and do this one. So 4x and x. I really can't blame this is how they thought it. Because this is really, I guess, how I thought it. They're like, oh, I could put a plus 3 and plus 3 and know that 12 plus 3, which is 15. Isn't that what we messed up? That's really how they teach it in the class. Okay. Anyway, though, this would be the result. I'm going to go the other way, though. My method, so 4 times 9 is a positive 36. Okay, what's the factors of 36 to give me 12? There's 1 and 36. 2 and 18, 3 and 12, 4 and 9, or 6 and 6. They all see 6 and 6 is 1, which is 12, right? Are we good there? So once again, I'm rewriting 4x squared plus 6x plus 6x plus 9. Group the front 2, group the back 2. This guy is a 2x, x, 2x plus 3. These guys have a 3, 2x plus 3. This is the answer of 2x plus 3 and 2x plus 3, which is 2x plus 3. That is called a perfect square trinomial, meaning it comes from a binomial square. It doesn't really matter. Is that any different than what we've already learned? Yeah. Okay. I'm not going to worry about that too much. Just like the difference of squares. We kind of already talked about that over here. For example, let's do this guy. What's missing in the middle? We're missing the 0x, right? So we understand that. Where I'm at there. Okay. So then I do the same process. 4 times negative 9 is negative 36. Factors of 36 to be 0 is negative 6 and 6. Anytime you're getting 0, don't have to be both the same number. Right? Did anybody remember what we called it in that difference in squares. You're going to remember where they always come down into B. Conjugate pairs. So this will come out, so we'll just rewrite it, and we'll see what it does. You guys probably think I'm the most boring person in the world. But, all right, I'll live my life. Greg, how was your early morning run yesterday? Last this morning, I can't remember when that was. Yeah. Mr. Huff, were you ever here around Huffy Puff time? You weren't, were you? You don't know Mr. Huff. You do? Who does? Yeah? Do you live within your religious neighborhood? Mm-hmm. Oh, I just don't live there. Did you swim with him? Gotcha. Anyway, he used to always say, swimming, the only sport you won't get grasshopper. Everybody else teaches you to breathe, right? Say again? No. But is it nice to see them? If you can see them, you can do it quicker, right? So and you see how on the bottom they do go to the conjugate pairs, right? So if you do see a difference of pairs, you can do this in a quick factor, is what I like to call it, without doing all that work. You know what I mean? If you can see that, then I can understand you just jumping right to the conjugate pairs. Okay? But what if you don't? Am I going to be mad at you? Just take time. You know what I mean? So how you do this quickly is just take the square root of him, square root of him, 2x and 3, just do different signs. But no, you don't need to know the names of them. How about this one? This one's a little bit trickier though. What's that called? Isn't that still a difference of squares? Different places, but still, meaning this is something squared, right? And this is something squared, correct? This is still a difference of squares, huh? Everybody there with me on that? Understanding how that works? Okay, now watch on this as I do this, just as we talked about. Do I have to go through all that whole steps? No, because basically what do? I take the square root of him, that's the square root of 16. 4, square root of him, is it just x plus y, because get rid of the square is the square root, get rid of it. So I have 4 minus x plus y. So right there, Brittany, does the parentheses matter? It does. And then this one's 4 plus x plus y. So basically I have 4 minus x minus y times 4 plus x plus y. Notice I did that in a quick factor because I knew they were difference of squares. So knowing that they are, that's kind of a nice thing to know just so you can do it quicker. But if you don't see it, you could probably still make this work. What would I do on this? I'd do kind of like a U substitution of this to make it a little bit prettier for your eyes, right? Because you guys see how it's very much the same idea. You just got to make it look something that your brain's like, oh, I know what to do with it, right? Are you good with me? Okay, the next thing we're going to do is I'm going to show you how to do a sum and difference of squares. Not squares, cubes. So if I have something like this, that is called a sum of cubes. Okay, once again, the name's not so important, but knowing what to do is. Okay, I'm going to go like this to you guys as well. Wink, wink. Chloe, what does that mean? That might be important. So, this is a sum of squares. This is a cubes. Okay? Okay, this is a difference of cubes. Once again, sum means addition, difference means subtraction, right? Okay, but they have a formula. There's no other way to factor this unless you memorize this sucker. It is what it is, okay? I could show you another way, but we skipped that lesson, 5-3. That's not one that we did. So I can show you another way, but it's not the way.
How many of you guys remember doing synthetic division back in secondary 3? That's with all those numbers, right? And you went like such and all that stuff. You could do it going off of here, okay? So that's where this can come from. But I'm just going to show you the formula, okay? So the formula is basically take the cube root of A. Who's the cube root of A? Q would be A. Who's the cube root of B cubed? B. So it's A plus B. Now, I need to go ahead and have something else that would multiply to get me to this result here. Okay? Does that make sense? So here's what we got. We have A squared plus a B squared. Now why? Because if he's A times by A squared, what do I get? A cubed. He's B times B squared. That'd give me B cubed. But I need to also have this middle term, which is just minus AB. Highlight it, star it, do something with it. Okay? Make sure you know how to use that. I'll show you how to use it in just a moment. Is the homework been too much? Can you guys be honest? Is it a lot? Are we okay? Okay? Yeah. My first time teaching this, I just don't want to overload you, but enough that you guys feel like you're confident in doing what we're doing. So then this, what would this one be? What do you think? It's going to be A minus B. Then it's going to be A squared plus AB plus B. Huh? Yep. Because notice what's a negative B times a B squared. That's how it is.
Will it give us A?
No, so let me show you what it'll be. Here's an example. Okay. So this is a sum of cubes. Right? How do I know it's a sum of cubes? Is 8 a perfect cube? 2 by 2 by 2, right? That gives me 8. Is 27 a perfect cube? Yeah, we kind of went over that whole list with you guys, right? Remember when we did that in 7172, right? Okay, so these are perfect cube numbers. What are some other perfect cube numbers just so they're in your head? 1's nice, 8, 27, 64, 125, 216. I don't know any more than that. I hope you don't need to know more than that either. 343, I think is one of them. But I really don't think you're going to go higher than 27 or even 64. Okay? So if you kind of know those, it can help you out, though. Yes, ma'am? This is called the sum of cubes. And this one right here is called a difference of cubes. They're both cube numbers. Does that make sense? All right. So with that being the case, what's the perfect cube root of 2x cubed? If I took the cube root of him, what would our result be? 2x, right? So 2x is representing who? It's representing my A value, isn't it? Does that make sense to everybody? It's a placeholder, exactly. So who's my perfect cube of 27? 3. Does everybody see how I got that? So who's representing my A? 2x. Who's my B? 3. Does everybody get what I'm saying by that? So remember, now we're going to go here and say, okay, A squared. What's 2x times 2x? 4x squared. And it should be 4x squared because 2 times 4 is 8. X times x squared is x cubed, right? Need to get back to there. Okay, my B value is 3, so when I square that, I get a positive 9. Right there. What's the middle going to be? So it's just 6x here, plus or minus? Minus. Because you do opposite of whatever this is multiplying, right? That's it. That's all you got to do. Then 9, I went from, notice that's my B value, correct? So it's B squared, so 3 squared is right here. I took the cube root of these. What is the cube root of 8? 2. What's the cube root of x cubed? X. What's the cube root of 27? Answer your question. Should we do another one of those?
Yeah.
You kind of want a little tricky, right? Okay, I'm gonna have you guys write one. I'm gonna do it, but I'm gonna let you try it. So let's do 27x cubed minus 64. How about you guys try that one? Because I can't go any further than that, by the way, because that secondary stuff of the a squared minus ab plus b squared will always be prime. I can't factor him anymore. I'm gonna push pause just so we're not recording. Okay, what's the cube root of 27? 3, cube root of x, cubed. Does everybody understand how I got 3x? Right, what's the cube root of 64? 4, so it's 3x minus 4. Does everybody get where I'm at there? Okay, with that being said, I need to square 3x. 3x, oh, yes? Nope, so it's always just see how that minus is already there? So it's still just going to be minus there. I get what you're saying. You with me though? Okay. So then I square 3x. 3x times 3x is 9x squared. Okay. Then I multiply these guys. Negative 12, but then do the opposite sign, basically. Okay. So that's plus 12x plus 16. Okay? Difference in sum of cubes.
And which one is different?
Sum is a plus, difference is minus. Okay. We're going to factor this guy. Yes, he's going to factor further. This time it's kind of hard to see how he can factor. But we're going to ignore someone a little bit. We're going to ignore that y squared. If that guy wasn't up there, could I factor him? Probably. So we're going to just ignore that y squared right there, okay? We're going to work just with him for a moment. Okay, what's the factors of 16 that get me to be 8? 4, 4. Does everybody agree with that? 4, 4? So this would be p plus 4 times p plus 4. I did that. I call that quick factoring. If this guy's ever 1, do I really go through the process of, nah, I don't need to. Because if I find the factors of him that work to this number, they just go in here. If that factor is a 1. If it's not, then I should surely do the rainbow method factor, right? Does that make sense? What is p plus 4 times p plus 4? We could call that p plus 4 squared, right? What's this called now? The difference of squares, isn't it? Because it's a perfect squared number and another perfect squared number again, right? Does that make sense, everybody? So in a way, do I need to know the names? In a way, it's just so you can see and recognize them, right? Okay, this is something perfectly squared, this is something perfectly squared, and what do same difference of squares going into? Do you remember the name that they go into? Conjugate pairs. You said it earlier, so that's why I went with you. So what's his perfect square? What's the number that's squaring here? P plus 4, right? Not 2, because it's this whole thing, right? It's being squared. Does that make sense? What's the perfect square of y squared? y. So it's p plus 4 minus y and p plus 4 plus y. There we go. That's factor. Snip that up. I've been actually doing pretty well this year. I've been taking my Allertech every day. No, that's what are you mostly allergic to? The first cut of hay that I always get. There's lots of them. Especially this little bugger over here. I love him to death. He cuts his hay in a very interesting format. All right. How was that? Are we good there, you think? That's 5-6. Okay. That's just different styles and factoring, right? Okay. Yeah, here we go. Okay. So now we're going to go to 5A. And we're going to start here first. So if I gave you this, what's different than what we've been doing? It's an equation instead of an expression, right? It's an equation because it's equal to 0. So with that being said, what is that saying? Is that saying 4x minus 3 plus x minus 1, 4x3 minus x minus 1, 4x minus 3 times x minus 1, 4x minus 3 divided by x minus 1? What is that saying? We're multiplying. When two numbers, because really this is two different numbers, right? Even though there's 4x minus 3, if I knew the value of x, would that not become two distinct numbers, right? It would be distinct numbers, correct? How does something become 0 when I'm multiplying? How does something become 0 when I'm multiplying? One of those suckers better be 0, right? Do I know which one? So I got to figure out what value makes each of these guys 0. Does that make sense? So I want to know, when does 4x minus 3 equal 0? So what do I do there? I'm going to go ahead and add the 3 over, right? Just basic solve. Then we divide. So x is 3/4. Let's plug that in. 3/4 times 4 is 3. 3 minus 3 is 0. 0 times whatever the crap this is 0. So that is an x value that makes that equation 0. Right? Is that the only number that allows us to do so? I want to know when he is 0 as well, don't I? What's that result? 1. So when x is 1, that result allows me to get a 0, correct? 1 minus 1 is 0. 0 times whatever that is 0. So these two answers would solve this equation, wouldn't it? Okay. Now, are all your equations going to be equal to 0 already? Are they already going to be in factored form? Probably not, considering we've done a lot of factoring going on right now, right? Probably going to still have you do some factoring. So let's do one right here. Let's say I have x squared minus 5x equals negative 4. Okay? I want to know when x squared minus 5x equals negative 4. But anytime I do this stuff, or when I'm solving, I want to get everything on one side, especially if there's a quadratic around. Okay? So what am I going to do? I'm going to, is it equal to 0 right now? It's equal to negative 4, so what am I going to do? Add 4 to the other side. Okay? That's kind of hard to understand when x is 0, isn't it? But if I factor it into my two binomials, which I've been doing, I can see that a lot quicker, can't I? Okay? So what are my factors of 4 that get me to be -5? -1 and -4, right? And because this is a 1 here, I'm going to do what I call a quick factor and just say x minus 4, x minus 1 equals 0. Now I'm at the exact same stage as the previous example, right? And I need to, are you okay? It would not be plus 5, because notice this would give me x squared, right? This would give me negative x. Negative 4x gives me negative 5x, but it does give me a positive 4, right? Answer your question? Okay. So once again, I have two numbers multiplying to become a 0. I want to know when x minus 4 is equal to 0. I want to know when x minus 1 is equal to 0. Okay? So what value makes this guy 0? 4. 1. Those are my answers. Could I plug it back in and check if I ever needed to? 4 squared, that's 4 squared is 16 minus 20. 16 minus 20 is -4, correct? Plug a 1 in. 1 squared is 1. Minus 5 times 1 is 5. 1 minus 5 is -4. Okay, so I could do a check if I needed to, right? Okay, how many of you guys remember doing this in the past? You've done this a lot, right? Okay, thank you for responding. Understand how in depth they get. Okay. Okay. What do we want to do first? Get 20 on the side. We always want it equal 0, because then when it's multiplying, we say, oh, well, it's multiplying. I just set each of these guys equal to 0, right? Okay. So I'm going to go ahead and get him over to the other side. I have a u cubed plus 5u squared minus 4u minus 20 equals 0. How are we going to factor this one? By grouping, okay? If you ever see a cubic, that should be your first thing unless it's a difference or sum of cubes. Does that make sense, everybody? Okay, so I'm looking, I see a group here, a group here. What does the front guys have in common? U squared, so I'm left with what? U plus 5, right? What do these guys have in common? -5. I'm left with a u plus 5. Like 4, Dingleberry, Robert. Sorry, guys. I know what I'm doing, I swear. Just like you guys know what you're doing sometimes, but I mark you wrong. It's all in fun, isn't it? Okay, so I plot the u plus 5. What's left over? U squared minus 4. Am I done? Why? I can factor him one more time, can't I? Right? Because he's called a difference of squares. What did difference of squares go into, Thane? Picking on you again. What? That's right, brother. See, it's going to be Thane's baby, those conjugate pairs. You know, rocket to sleep. Okay? So u squared minus 4, as he just said, goes into conjugate pairs, which is just u minus 2 and u plus 2, right? So this time I have 3 different numbers, right? Because I have I have 3 different binomials. You guys see that? So I'm going to have how many answers this time? 3. What's the value makes him 0? -5, do we see that? What's the value makes him 0? 2. Either way. And he is -2. Okay? We do a story problem together? We're going to have some story problems. Okay, if you have your book, get it out. I'm going to let you guys choose which one I'm going to do. Go to page 433. We'll do any of those that you want to do. Starting with 71 through 82, 83, 86, whatever. Okay? Which one? Look down, look through them. Let's do about 3 of them. Which one do you want? 76. Consecutive integers. Okay. So this is number 76 on page 433. It says the sum S of consecutive integers, blah, 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 is given by such. Okay, that is 1 plus 2 plus 3 plus blah, blah, blah is that. How many consecutive integers will be added together to obtain a sum of 36? Okay, what am I going to put in? 36 in for what? S, right? Yes, ma'am. This is 76 on page 433. The one right above the cows. So 36 equals n plus 1 times, sorry, I'm just writing that backwards because I messed up, over 2. Does everybody agree with that? How am I going to solve that? Well, how many of you guys want to play with the fraction first off? Oh my goodness, I don't see one freaking hand. Because I wouldn't either. So how are we going to get rid of that sucker? Times it by 2. Now what? Anybody? I would distribute. Is everybody with me on that? Okay. So isn't that n squared plus n equals 72? Do we want the 72 on that side? Am I going too fast? I am, guys. You guys just gotta hold me up a little bit, please. I don't mean to, but when I don't get a lot of conversation, I just, okay, we're good to go. Because I can do this quick. This is my job. That's what I do. Factors of 72 that get me to be 1. 9 and -8. Everybody agree with that? And I'm doing a quick factor because once again, it's a leading coefficient of 1, right? Is everybody there with me? So what's n? -9 and 8. But we're in the context of a story problem, aren't we? So does both of those answers seem reasonable? What does n represent? The consecutive integers, correct? And I have -9 consecutive integers. That doesn't make sense. It's gone. Does 8 consecutive integers make sense? The first 8 consecutive integers? 1, 2, 3, 4, 5, 6, 7, 8. If I add those up, I would get 36. Okay. Does that make sense to everybody? It would be equaling it. Even though I got 2 results, there's only 1 answer, right? Okay, any more on that page or flip over and see the other side? How about that 78? That looks fun. Do that. I like 78. Okay, 78, it says, a farmer has 300 feet of fencing. So that's how much he can fence. And he wants to enclose a rectangular corral that borders his barn. So we're going to have a barn. Here's my barn. Horses. Nay. Okay. I love horses. Probably the best animal that's ever roamed the earth. Think of our world without a horse. Every year I say this. Huh? Well, she was dying anyway. You might as well get some money. It's hard. You cry a little bit, but then you're like $600. No? You guys don't feel that? No. All right. I'll shut up. I'm sorry. Okay. All right. A rectangular corral that borders his barn on one side and divides it into 2 plots. So we're going to have a corral, but he wants to divide it. Does it have to be equally? I don't think it has to be equal. It just says 2 plots. Okay, with fence parallel to the other one, as we see here. Assuming that the farmer will not fence the side along the barn, because why would you? Okay, what are the lengths of the parts of the fence if the total area enclosed is 4,800 square feet? Okay, 4,800 square feet. That's our area. All right. So how much feet of fencing do we have? 300. So let's call this guy right here X. Because I don't know how much feet of fencing that is. Do you guys? I don't know how much he wants. What do you guys know about this amount then? He's the same thing because it's going to be the same distance, right? Okay, what about this guy? Same thing. You guys with me on that? Any questions on that? Okay, what's this length going to be? How much 12 feet of fencing do I have? 300. How much fencing have I used? 3x, haven't I? So to use the leftover, wouldn't that be 300 minus 3x? Everybody with me on that? Once again, just kind of thinking about it. What if you couldn't think about that? Put a value in. What if he's 10? Then you go 10 plus 10 plus 10, which is 3 times 10. And I'd go 300 minus 30. Kind of gives you the same idea, doesn't it? Okay. Now, it said area, right? What's the area of that corral? It's 4,800 square feet. We do know that. That's true. But what's the area in terms of our variable? What's the area of a rectangle? Length times width. My length is 30 minus 2x. 3x, excuse me. Ooh, Betsy. Ooh. People have been mocking me on driver's ed because I've been saying, whoa, Betsy. Sure. And that was Betsy. There's our length. Who's our width? Not 3x. Who's our width? Just x, right? Because this whole area is still 408. Does that make sense? Right? Okay, what are we going to do there? Oh, somebody got it. I love it. Okay, so I get negative 3x squared plus 300x equals 4,800. Can I ask you a question? Do you guys want to work with such huge numbers? What do they all have in common? Let's just divide that crap out, right? So what is 4,800 divided by 3? 1600 equals negative x plus 100x. Oops, squared. I lost my squared. You guys like a negative x squared? Oh, I know why. It makes me feel awkward and weird. That's my first thing. Never had an awkward date, I'm guessing. No? Been pretty good for you? Good for you. Uh-oh, did I mess up there?
Oh, yeah, because you switched the time.
Yeah, I'm good. That's a slight dilemma because I don't know how to factor this sucker. I don't want to look like an idiot. I'm pushing pause for it. So we can't factor. Yay! And I can't believe I just didn't do it. I was like, nope, I can't. I'm not gonna do it. Don't be like me. Don't not just try. 20 and 80. I'm such a dingleberry. Oh man. Have I explained what a dingleberry is? Poop hanging off an animal's bum. I used to have one girl that would freak out every time I say dingleberry. She's like, ew! Really? She actually coaches here now. Maybe I cheerleader. No, burgundy. So, x can be 20 or it can be 80. They still give me the same area. Okay? Swear. So let's check. So if that's 20, that's 20, that's 20. How much is that? 60, so that's 240, right? 240 times 20 is 4,800. If this is 80, this is 80, this is 80, how much is this? That's 380, that's 240, that would be 30. Right? No. 60. 80 by 60 is 4,800. You guys want another one, or are we good? Uh-huh. Nope. Because, let me show you why. I'll explain why. Maybe you're wondering why it doesn't work, but I'll show you why. If I do something to both sides, well, technically I never got rid of a negative, did I? Because I added him over, and I subtracted him over. So I never got rid of it. The 3, you would like to, do you understand that the 3 is gone just because I divided every single thing? Yeah. That teeter-totter method, as long as I do one side, I do it to the other, I should be okay. Yes? You guys want another one, or are we good? Nope. Here it is, because what value makes this guy equal to 0? So I said, when does x minus 20 equal 0? 20, right? When does x minus 80 equal 0? 80. Brittany? Nope, so I put 20 into all the x's below. Okay, so that's 20 plus 20 plus 20 is 60. So how much centimeters am I left with? 240, right? That's a 20, so on an area, 20 by 240 is 40. Does that make sense? And then if I have 60, or excuse me, 80, 80, 80, right? That's 240 feet, so how much is left over for my length? 300 minus 240, 80 by 60 is 40. Okay. I am. I want to go get, how many of you guys wanted that review? I was going to get you a different review page. Like one, so I don't have that printed, so that was kind of my goal to run out there. Is that fair? Okay. All right. Let's go. We'll fly up with the mountain side. Let's go fly a kite. I don't know if that's right, but I made it. I named it that way. So. This is both on page 443 is where it starts. Oh, this is not 7, this is 8. Okay, I'm gonna go print something off and then we'll get going, okay? Any questions?